No, a P plus resistor. Well, let's come back to that one. We'll do that one after we do the poly. You have to put it in an N well, because if you put the P plus directly in the substrate, what does it do? It's connected to the substrate, which is at ground. Yeah, so it doesn't do anything. So we'll do that in a second. Okay, so I've got 22.6 ohms for my resistance. So roughly 45 squares or something like that of resistance. Does everybody see how I looked up the sheet resistance there? It says I have 16.2 ohms of contact resistance. So I go over here and I say Control N, and I'm going to make a layout. Whoops, I need to put a name in there, don't I? Let's put 1K poly R. Now, I can do this several ways. And one is, I can, well, let's see, I can put this down, which is what? Poly to metal 1. So let's hit fit. So this pink is polysilicon. The blue is metal 1, and the dark is contact. Let's hit the 3D viewer. And I see there's my metal 1 contact to polysilicon. I can go throw down, if I hit expand, another, at this point I'd want to send it, yeah, let's just do this. Let's be different. You can calculate the number of squares. I can then go through and I can, whoops, let's go select this. Now I've made a resistor. How do I count the corners? 0.6 of the sheet resistance. So I count up the number of squares I have in this direction. Now I'm going to do a DRC. 3 errors. What do you think the errors are? Poly to poly spacing. So let's see. Okay, that poly, what does that say? Okay. Less than 2, so let's go take this down, slide it a little. What's the error for a poly to poly error spacing? Well, you want to make sure that you have enough distance in here that you don't get a leakage. Because remember, we're talking really tiny distances between the two materials. Okay? So let's hit fit. Let's see how we did now. Oh, what is going on with that? Yeah, I never have to close electric. I can keep it running all the time normally. I don't know. I think it's Vista. No, it doesn't like that. Alright, anyway, I'll send him another question about that. We'll make sure that works. Okay, so let's do a 3D view. Okay, so there's my resistor. Are there any questions about estimating the resistance? So my contact resistance would be 16 ohms from the metal down to the polysilicon, and then 22 ohms for every square between here, between the two contacts. I could also go over here and press Control. Why isn't it? And export. What's that? Yeah, you count from the edge of the contact, but again, it's kind of a waste of time because the polysilicon sheet resistance is going to vary quite a bit as well. So you just want to get close, and then we'll show about using unit cells, how to go from there. Yeah. So use 0.6. 0.6 times 22 ohms. So for every corner. Now, here's a simple question. Why would I want to... I'm laying out a 1K resistor. I'm going to have 50 squares. I don't know how many I have here. Probably not 50. Why would I want to lay it out in a serpentine pattern? Makes the layout smaller, right? If I laid it out, and don't do this because especially in your projects, don't lay anything out as like one long thing that's like 2 millimeters in length. And so you look at it and it looks like a thread in a piece of cloth or something when you're looking at the full-blown layout, all right? Do it, the way we're doing. If the layout's different than what I'm doing, it's probably not good. All right. So I can export these two connectors. Let me show you another way to do this problem. Let's delete this. We can go and say, oh, I don't want to have a metal connection. I want to connect with poly for whatever reason. So I can go over here and I can put it down a pin of poly, and then go over, like this. And then now I can export this pin on the polysilicon, or this pin, or any pin in the middle as an export on the higher ranking cell. I can go up here and go, oh, this one is T, and this one is B. Yep, 3D view. It's not connecting to anything right now. So it's just, if I were to use this cell, let's do it. Let's put it in a temp cell. Let's go, let's make another temp. Let's do a Control N, layout, temp. So now if I go and I drag this down here, let's show it. If I'm going to make a connection or I'm going to run it out, I run it out like this, and that's my wire, and then I can hide this and show the connection inside. Okay, now if I wanted to go back and I wanted to connect this cell up to a bonding pad, what would I do? You go and say, oh, I can put down a poly metal contact, zoom down there, now I'm connected, put one over here, go over, I'm connected, and that's sloppy, etc. Move things around, and now I've got my connection. I can go over here. Oops. Let's throw down a pad. Let's do our full-blown pads. We can go in on metal 1, 2, or 3. That's because our pad has all 3 metals. I see confused looks. So if I only had a pad here that only had metal, here, let's do this. Let's duplicate this cell. Duplicate the cell and just call it pad metal 3 only. Then let's go over to this cell. It's got pad metal 3 only. So I'm going to just delete everything. Now, how do I make, we'll leave that there because we need it. How do I make a metal 3 pad only? Pure layer. Now, does that work for connecting down to metal 2? It does if I do it right. I go replace metal 3, put a metal 3, metal 2 contact, do a Control I, a 250 by 250, and now I've got a connection, right? Okay, so let's go put a metal 3 node down. Just drop it somewhere in there. Control I, 0, 0, 250. These are bond pads. They're 75 microns by 75 microns actual size. Probe pads, which are not bonded out, which are not connected to wires, can be considerably smaller. They can be 5 microns by 5 microns so that when we go look at our layout, the pads don't dwarf what we're measuring. Okay, so there's my connection to metal 3. I come back to any questions on that? I come back to the cell I was just working on, which was temp lay. Let's see if I can press, if I want to change that and leave it in the same position, what could I do? Press C for change and go to metal 3 pad only. Done. Now I've got, if I zoom, let's do a 3D view. I can see, there's my metal 1 down there, if you can see that. Let's zoom in. There's my metal 1 down there. I need to snake it up or get it up to metal 3. However, and I know how to do that, if I go back and I do a Control Z, and I use metal 1, metal 2, metal 3 pad, and then I show, hey, you know what? I can go directly over because that pad has all 3 metal layers. And I can just do this. Whoops, let's put it on metal. There we go. Put it on metal and just go over. And now I'm connected up to the pad. And that's because I have all 3 metals on the pad. What's that? Yeah. Well, in reality, what depends? What's real? If it was a product, then chances are I'd have 1 point and they'd tell me where I'd have to connect and on what level. If it's a research project and I'm lazy and I just wake a pad up because it takes me 3 seconds and I go through and I know that the bonding pad capacitance is tiny compared to what I'm driving off chip, then sure, because then it'd be easy for me to do this in a minimal amount of time. Okay, does anybody have any questions on this? Is it making sense? Okay, does everybody understand how you would use a polysilicon as a resistor? Okay, so now, you say, all right, I understand that. Oops, let's zoom in here. Okay, so let's go back. And we said, okay, we can use the polysilicon as a resistor. Let's